Hey students, this video is going to go over types of matter and states of matter. So you're going to be taking notes on page 3 of your packet. We're going to go through numbers 1 through 10, although this video will not go over all of those questions. The second video will finish it up. So first we want to talk about what is matter. When you hear that term matter, what does that mean? Well, matter means that it has mass and takes up space. It has to have both of those conditions met. So the mass does not have to be like a really big, significant mass. It could be something that's very light. That's why gases, such as the air around us, are considered matter because they do have some mass associated with them. And then they have to take up some kind of space. Again, it doesn't matter how much space they take up as long as they do that, taking up space, and that they have mass. So we think about the stuff that's around us, the computer that I'm on, this pen that I'm holding, the clothes that we're wearing, the water that I'm drinking. Those are all things that are matter. The air that I'm breathing, that's matter. So what is not matter? What does that look like? Well, it doesn't really look like anything, but what's not matter is, sorry about that, any kind of energy. So heat and light, those are two things that represent forms of energy. Those are not matter because they don't have mass and they don't take up space. Sound, rainbows, those kinds of things, those would not be considered matter. So matter falls into two categories. We have pure substances and we have impure substances. So pure substances are those that have definite and constant composition, and they cannot be separated by physical means. So that means that we can't, boil off water and be left with salt. We can't, filter something out and be left with something else. So we can't use any kind of physical means to separate them. We can use chemical means in some instances, but not physical means. So we have two types of pure substances. We have elements and we have compounds. Now, elements are those things that are going to be found on the periodic table. Those are the simplest forms of matter, okay? So if it's on the periodic table, it's an element. So sodium, neon, helium. Okay, you're all familiar with helium that you use to inflate your balloons at birthday parties and things like that. That's an element. Compounds are when we take two or more elements and we chemically combine them together, such as salt, the food that, what we put on our food to make it delicious. That has sodium and chlorine in it. This picture of bleach down here, that is a compound because it has sodium and chlorine and oxygen. Water, one of the most common compounds. It has some hydrogen and it has some oxygen. You're always going to see water having 2 parts of hydrogen for every 1 part of oxygen. That's what it means by definite and constant composition. With salt, for example, it's always going to have 1 sodium for every 1 chlorine, definite and constant composition, okay? Impure substances, these do not have a definite composition. It could change, and it can be separated by physical means. Okay, it can be separated by physical means. Like in this picture of these jelly beans here, we can pick out the yellow pieces, we can pick out the green pieces, we can pick out the purple pieces. With Gatorade, we could boil off water and we could be left with some of the sugar and the salt. Pizza, that's an example of a mixture because it's got a bunch of things on top of it, sauce and cheese and the bread and whatever toppings you want to put on it. Those are all mixtures, okay? Even the air that's around us is a mixture because it has a lot of different gases that are in there. That's why we have a picture of air. So it has nitrogen and oxygen and carbon dioxide and even water vapor, some argon. So there's a lot of different gases that are floating around us. There's 2 types of mixtures. We've got homogeneous mixtures and we have heterogeneous mixtures. So homogeneous mixtures, the prefix homo means the same. Homogeneous mixtures are where we cannot see the different parts of the mixture. It does look uniform to us, okay? So we can't see the different parts to it. So these pictures up here on the right side, those represent homogeneous mixtures. We've got milk If you've ever heard of homogenized milk, if you look at your milk label, it'll say that. We can't see the different parts of milk. When you make your Jell-O, you can't see the different parts of the Jell-O. This here, this is a mixture of metals forming the surface of the penny here. Solutions, this is a big part of chemistry, and those are homogeneous mixtures. It's got some kind of solid dissolved in water, and we can't see those different pieces. The heterogeneous mixtures, this is where you can see the different parts of the mixture. So we've got oil and water. That's a classic example of heterogeneous mixture. Sodas, heterogeneous mixtures, because you can see the gas that's dissolved in the soda. You've got, Italian dressing, chocolate chip cookies, delicious. You can see the chocolate chips, okay? Heterogeneous mixtures. So this flow chart does a good job of representing those different types of matter. So you can see the first question you should ask yourself is, can it be physically separated? So yes, on this side, let me grab my annotate tool here. On this side over here, these would be our impure substances because they can be physically separated. These over here, as you can see, those are our pure substances, okay? If it cannot be separated by physical means and it's a pure substance, then you can ask yourself, well, is it the simplest form of matter? Is it on the periodic table? Okay, elements are going to be found on the periodic table. These are where you have two or more elements together. Okay, so you can find those on the periodic table, but you're going to have two or more chemically combined. They have to be chemically combined. Over here, if they can be physically separated, you've got a mixture, and there's, remember, two types of mixtures, your homogeneous and your heterogeneous mixtures. You're looking to see if the composition is uniform. Can you see the different parts of that mixture? Because that's going to let you know if it's a homogeneous mixture or if it's a heterogeneous mixture, okay? So that is our types of matter. Let me clear these drawings here. And we're going to talk really quick about the states of matter in a second. All right, so what type of matter is it? So here we've got graphite. It tells us that it's a form of carbon. Carbon is on the periodic table, so that is an element. Pepper, is it on the periodic table? No, it's not on the periodic table. Can you physically separate it? Yes, you can see the darker pieces. You can see the lighter pieces. So that's why it's a heterogeneous mixture. Sugar, which is sucrose. Now this is a compound because it contains carbon, hydrogen, and oxygen in a specific ratio. I believe the formula is C11H22O11. You don't have to know that. We would give that information to you. Paint, can it be physically separated? Yes, it can. It's not on the periodic table. Can you see the different components of paint? Nope. So it's I would say homogeneous mixture, but it's probably heterogeneous because it would settle out if you leave it sitting for too long. Soda would be a heterogeneous mixture. I would not say solution here. I would say a heterogeneous mixture because you can see the bubbles. You can see the gases in there, and that's what makes it a heterogeneous mixture, okay? Solutions tend to be homogeneous mixtures. All right, now different states of matter. So this is where we're looking at solids, liquids, and gases. You're looking at the particles, how closely those particles are packed together. You're looking at the movement of particles, and you're looking at the shape and the volume of these things. So when you're looking at solids, solids have very, very tightly packed particles together, and they do move. They have some vibration amongst those particles, but there's not a lot of movement. It's just very, very small vibrations, okay? Solids have a fixed shape and a fixed volume, like this pen here, okay? Liquids, when we're looking at liquids, there's a little bit more space between the particles. There's a little bit more movement between those particles as those particles slide past each other. There's no fixed shape of a liquid. My water, for example, it's going to fit my container. It's going to move around. is going to change shapes based on how I'm moving around my water bottle, but it has a fixed volume. I can pour it from this bottle into a different bottle, and it's going to have the same amount of space. Then gas particles are the furthest particles apart. There's a lot of space between gas particles. There's a lot of movement. They're very fast moving particles, okay? Gases have no fixed shape and they have no fixed volume, meaning that we can change the shape of them by putting gases in different containers. They're going to fill the container that they're in. That's why they don't have a fixed volume. Now, there is a word I want you to know for gases, and that word is compressible. Where it says here that it can be squashed, that's what compressible means. It means that we can take it from here and we can squish it to here. Okay, so that's compressible from here to here. And that's your states of matter. Okay, so make sure you do the practice so that you can make sure you're understanding these kinds of topics. Let me know if you have any questions about it, and yeah, good luck. Bye.